In this question paper, we are looking at the 2024 preparatory exam paper. We are in paper 2 in question 3 that deals with BMI and measurement. So we are looking at a BMI chart, how to calculate the percentage increase, how to calculate a circumference, and then we are also looking at the surface area of a cylinder and a volume of a cylinder. Question 3.1 says Mrs. Masinya gave birth to 2 twins, a boy and a girl. She monitored their weight over the first 6 months and summarized as shown in the table below. Table 1 shows us the weight of the babies over 6 months, starting with their birth weight up to their 6-month weight. It says use the information in table 1 above and the growth chart shown in annexure B to determine which description correctly represents the twins' growth over 6 months. Write down the question numbers 3.1.1 to 3.1.5 followed by true or false. If false, correct the statement. So for everything that is false, we are going to write the correct statement. If it's true, then we leave it as is. So looking at 3.1.1, it says the baby girl lay in the 10th percentile when she was born. So what you are going to do is you are going to look at the baby girl's weight when she was born, which was 3.2. And then you are going to go to the growth chart. The growth chart, be careful, there's one that says male infant and one that says female infant. So we are looking at the female infant. We are going to look at the birth. At birth, you are in months. So we are looking at 3.2 on the y-axis, meaning the horizontal side that says, the vertical line that says body weight. So we are going to look at 3.2 where it could be 3.2 in the line on the horizontal, meaning the age in months, where it matches the 0. So basically you are coming from 0 coming down and you are coming at 3.2 coming from the side, and where they meet, the graph on which they meet on, that's what we call the percentile line. Now you will see those graphs, they are going in a curvy way. If you meet it at its beginning, it's still the 10th percentile line. So just because it's not in the same view as the 10 as you are seeing, if it's at the bottom but it's still the 10th percentile line, then the baby is on the 10th percentile. So we are looking at 3.2, so it will be a little over 3. So I'm seeing a graph there that starts there because where it says a little over 3 and 0, so that's right at the beginning, and I'm already seeing I'm at a foot of a graph, and when I trace that graph up, I'm seeing that it's actually the 25th percentile line. So that means the answer to this question is, it is false. She's in the 25th percentile line. So you will write it in full. The baby lay in the 25th percentile. So I'm just writing 25th percentiles just so that you get the picture. But when you're writing it in the exam, you'll write it in full. The baby lay in the 25th percentile. If you're pressed for time, then you can do this. At least you will get those marks. 3.1.2 says when the baby boy was 3 months old, only 10% of other baby boys were heavier than he was. So when they say when you are a certain age, only 10% of other babies are heavier than you are, it means you have to fall on the 90th percentile. Because when you're on the 90th, we are talking about percentiles, we are talking about a full percentage, right? A full percentage is out of 100. Right? So if a full percentage is out of 100 and there is only 10 that is above you, that means you have to be in 90. Why? Because when you start taking 100, you minus 90, you are left with 10. So if you fall on the 90th percentile, then only 10% will be above you. So that is the 10% that moves from 90 to the 100th percentile, if I'm making sense. So we are going to just verify that at 3 months old, did the baby boy fall in the 90th percentile? If he does not, then the statement is false. But if he does, then the statement is true. So you are going to look at your male infant chart, and at 3 months old, his weight was 5.9. So we are going to trace 3 months from the bottom and match it with 5.9 from the side. 3 months from the bottom, match it with 3.9, with 5.9 from the side. And no, you can see that he falls under the 50th percentile, not the 90th percentile. So the statement then becomes false. He is in the 50th percentile. Therefore, 50% is heavier than him. How do I get this 50%? Because at 50th percentile, it means you are at 50%. So 100 minus 50, you are left with the other 50. So 50% is heavier than him. 3.1.3 says, at the time the twins were 6 months old, they both lay close to the 50th percentile. So we are going to check both twins. Now, at 6 months old, let's start with the boy. The boy weighed 0.8. So we are going to look at 0.8 on the growth chart in conjunction with 6 months old for the boy. So at 0.8, at 6 months, did the boy lay close to the 50th percentile? When you trace it, you see that that is actually true. He lays very close to the 50th percentile. So for the boy, it is true. And then we go back to the girl now. The girl's weight at 6 months was 7.4. So we are going to go on the female infant chart and look at 7.4. So that would be a little above the 7. And then we are going to trace the 6 months, and we see that it's on the dot that is right on top of the 50th percentile. So we can safely say that this statement is true. And then in 3.1.4, at 6 months old, both babies were developing at the same rate as the average growth rate. So at 4 months old, the boy was 7.0 and the girl was 6.4. Going back to the growth charts, we see there's a little note under the male infant chart. It says, note, the dots represent an average growth rate. So when we are saying they are growing at the same rate as the growth rate, we are saying that at those months, at 4 months, all of their weights fell right on top of the dots. So they have to be right on top of the dots. So when we look at the boy's one, remember the boy was at 4 months 7.0. At 7.0 in 4 months, we see that he is right on the dot. We see that the boy is right on the dot. And then we're going to do the same thing for the girl. We're trying to see that she's going to also be right on the dot. At 6.4 in 4 months, we can see that it's also right on the dot. So the way I look at it, it's right on the dot. There is an argument for the girl being a little below the dot. So if you said it's a little below the dot and you're saying that this, then your statement would have to be false and you would have to tell us why. But if in your chart it looks the same way that it looks to me, that it falls right on the dot, then my answer is true. So what's important here is that to justify your reasoning, whatever your reasoning is, if you can justify it, then you can get the answer. But for me, the way I see it is right on the dot. So Therefore, the boy is on the dot, the girl is also on the dot, so therefore my statement becomes true. But if your girl is not on the dot but the boy is on the dot, then that means your statement would be false because the girl is not on the dot, because the statement said both of them, so it would have to be both of them, it can't just be one. Then the last statement is 3.1.5. The baby boy's mass increased by a little more than 139 in the first 6 months of his life. So this one doesn't need a growth chart. In this one, we are calculating the percentage increase. So a percentage increase usually is a very common question. It has a very simple formula. So it's whatever the new value is. So new value minus old value all over old value multiply by 100. I'm saying value because in some questions they were talking about a difference between populations. In some questions they're talking about the difference between prices. Whatever you will be dealing with, the new value minus the old value all over the old value. So in this case, what we are saying is he started at, this is the boy, he started at 3.6, now he weighs 8.0 at 6 months. So this becomes the old rather, and this becomes the new value. So basically you're going to say 0.8 minus 3.6 all over 3.6 multiplied by 100, and then you're going to punch in your calculator and you will see that it will give you 122.222%. So therefore the statement is false, and that is the rest of 3.1. In 3.2, we are dealing with measurement. It says, due to the increase in the size of his family, Mr. Masenya decided to purchase a bigger geyser. The family purchased a 200-liter geyser, twice the size of their old geyser. A table showing the dimensions of standard horizontal round geysers is shown below. So we have table 2, it shows the capacity of the geysers, and then it also shows us their diameter and their length, starting with a 50-liter geyser to a 250-liter geyser. And then it says, study the information given in table 2 above and use it to answer the questions that follow. The first question, which is 3.2.1, wants you to write the dimensions of the old geyser. Now, we know that the new geyser is a 200-liter geyser, and they told us that this 200-liter geyser that is new is twice the size of our old geyser. So if it's twice the size of our old geyser, it means that taking the 200 and dividing it by 2, I'm going to get the size of our old geyser, which is 100 liters. 3.2.2 says, calculate the circumference of the base of the new geyser. You may use the following formula. Circumference of a circle is equals to pi times diameter. So we are now going back to the new geyser. We are not dealing with the old geyser anymore, meaning the 200-liter geyser. That's the one whose circumference we are calculating right now. So they're telling us that it is pi times our diameter. Remember, our table 2 shows us diameter and length, so we are just going to go there and find our diameter. So our diameter for this geyser is 550. So you're looking at the 200-liter geyser. It says 550 times 1.470. So we are just interested in the diameter, not the not the length. So you can punch it like this in your calculator. In your calculator, if you're looking for pi, you're just going to say shift and times 10 there. You will see in yellow right above it, they have a pi. So that is going to give you your pi, and then you're going to multiply it by 550, and then it's going to give it to you. That way you press SD, or you can use the pi that they have given you there. They said it's 3,142, and then multiply it by 550. This is safer in case you forget where to find your pi. So it should either way still give you 1,727. It's 27,8. So when I round it off, it's going to give me 1728 comma something. So that's going to be the difference of the commas there, just because the pi is more accurate and the 1.347 limits that a little bit, but your answer should be correct either way. So with this, you will see it gives 128,1. Either way, you will still be correct. Both of the answers will be acceptable. It's just the difference of decimals. So don't worry too much about it when your answer is a little bit different. So long as it's 1,728 or 27,8. When you round it off, it's just the difference of rounding off. In 3.2.3, Mr. Masinya claims that because the new geyser has twice the volume of the old geyser, the surface area of the new geyser will also be twice that of the old geyser. Verify whether this claim is correct. So we are trying to see, is the surface area of the old geyser of the new geyser twice that of the old geyser? So this question, you will see that it's also 8 marks, because it's requiring you, before you can answer that statement or give the statement that verifies whether his statement is correct or incorrect, you have to calculate the surface area of both geysers, hence the 8 marks. So for both geysers, so you can start with the old geyser and calculate that surface area, and then once you're done with that one, you are going to calculate the surface area of the new geyser, and then you're going to see if, or you are going to show with calculation, is it twice that of the old geyser. So let's do it so that you can see how we do that. So let's start with the old geyser, right? And you will see that we have been given a formula that we can use to calculate the surface area of both geysers. It says surface area of a closed geyser is equals to 2 times pi times radius square close bracket plus 2 times pi times radius times length. So now you will see that in that formula we are talking about radius instead of diameter. In our table 2, we have been given diameter, and they want radius for the formula. So how do you get radius when you have only been given diameter? For those of you who don't know or forgot, you take the diameter that you have been given and you divide it by 2 simply, and it gives you your radius. So in this scenario, remember our diameter that we have been given in the table was 550 divided by 2. So you will just say 550 divided by 2, and our radius is 275. So everywhere where it says radius, this is what we are going to substitute. So starting with this total surface area, now we are going to say for the old geyser, 2 times our pi, they told us to use 3,142 multiplied by radius square. Radius is 275. Remember to square it, close bracket, open bracket, 2 times, again, our pi is 3,142. Our radius is 275, multiply our length. The length for our old Geyser, this is the 101, so we go back to the table and we see that it is 840. 1,926,831.5 millimeters. Don't forget your square every time you do an area. So this is the surface area of the old Geyser. We move on to the surface area of the new Geyser. So this is the 200-liter Geyser. We again substitute 2 times 3,142. We use the same formula, right? And they had the same diameter, so that means their radius is also going to be the same. So 550 divided by 2, you are still going to get 275 square plus 2 times 3,142 times the radius, that is still the same. The only thing that changes is the length. Now for the new Geyser, the length is 1,470. Punch the whole thing in the calculator and it gives you 3,015,534, again millimeter square. So now we are trying to prove that this is twice this amount. So the best way to do that is, if I divide this by 2, it should give me this. If it does, then his statement is true. But if it doesn't, then his statement is incorrect. So I'm going to take this amount and divide it by 2. So 3,015,534,5 divided by 2. How much does it give me? It gives me 1,507,767.25. This is not that. So therefore, his claim rather, is incorrect. That's how you get your full 8 marks. 3.2.4 says Mr. Masinya wanted to be sure that he stated the capacity of the geysers correct, so he performed the following calculation. It says for the old Geyser, which is 100 liters Geyser, he said volume, which is equals to pi times radius times length. And then he substituted for pi, he substituted the pi, which is fine if you know where to find it in the calculator. For radius, he used 550, which was the diameter, remember, not the radius. And then he multiplied by the length of 840. And then he said it gave him that number. I don't know how he was going to pronounce that number. And then that number was supposed to be converted to centimeters, and which gave him 79,827,869,33. And then converting it to liters, it gave him 79,828. It says note, it takes 1,000 centimeter cubes to convert to 1 liter. The question says identify 2 possible errors that were made in the calculation above. We have already seen the first error and we have already stated it out. The first error was that in the radius he used 550 instead of 725. So in radius he used diameter and did not divide it by 2 to get radius. That was the first mistake. The second mistake, which is error 2, you will see it's that number that I could not pronounce. Why? Because you will see that from millimeter to centimeter, it's actually the same number. He did not do anything. He did not convert from millimeter to centimeter. He just wrote it different, and he just wrote it in a way that we do not write numbers. Look at the last 69. It's just 69 and then comma 33, and then that same number he writes it proper when he now says he's supposedly converted it to centimeters. So basically he did not properly convert from millimeters to centimeters. He did not properly convert from millimeters to centimeters. So those are your 2 errors. You can even go further and explain how he should have converted from millimeters to centimeters. You can say by dividing by 10 cube, because it's volume. So you know that when we write the units in volume, we have to use cube. So even with the conversion, you know that from millimeter to centimeter you divide by 10, but if it's volume, you add the cube on top of the 10. If it was area, you would have added the square. So because now it is volume, it should have been 10 cube, or in other words 1,000, because 10 cube is 1,000. So you can either stop here, he did not properly convert from millimeter to centimeter, or you can continue and put it so either way you have identified 2 errors in his calculation. In 3.2.5 it says calculate the capacity of the new 200-liter geyser. Round off your answer to the nearest liter. You may use the formula volume is equals to pi times radius square times length. So we are working with the volume of the new geyser, which is the 200-liter geyser. So volume is equals to pi, we were told is 3,142 multiplied by our radius that we calculated to be 272 square, multiplied by our length, which was 1,470, and that gives us a volume of 349,229,212,5 millimeter cube, because we are dealing with volume. Now there was a note right under our formula that told us that 1,000 centimeter cube is equals to 1 liter. So this is in milliliters. So if I can convert this to centimeter cube, then I will be able to then convert that to liters. So I need to take this to centimeters. To take millimeters to centimeters, we divide by 10, and because we are dealing with cubes, it's going to be 10 cubes, or rather 1,000, because 10 cubes is the same thing as 1,000 if you check it in your calculator. So you are going to divide this by 10 cube or by 1,000, and it is going to give you 349,292, 2,125 centimeter now cube. Then because to move from centimeter cube, or rather 1,000 centimeter cube is the same thing as 1 liter. To get there, I'm just going to divide by now 1,000, and it's going to give me my answer in liters, and that is going to be 340 349,292 liters. That is my 2.5. And then in 3.2.6, my question says, should Mr. Masinya be happy with the new Geyser based on the capacity, this capacity that we have just calculated in 3.2.5? Provide the reason for your answer. I would say yes. Remember, Mr. Masinya was buying a 200-liter Geyser, and what he got was a 300 and something liter Geyser. So yes, because he gets more than 200 liters. He gets more than 200 liters of water in that same Geyser that he thought was a 200-liter Geyser. It gives him 349. So it's like 149 more than he would have purchased. Anyone would be happy with that kind of purchase. So that is the end of our question 3. Stay tuned for more questions on this same paper 2 of the preparatory paper from 2024. To have YouTube recommend you more of my videos, be sure to click the like button and subscribe to the channel. And if you have any questions, leave them in the comment section below.